All right, hello guys and gals. I am so bummed that I can't be here with you today. This is like one of my favorite lessons because we get to sing in math. So if you don't have it out already, will you take out your packet and a pencil? And it would probably be a good idea to grab a calculator too. And then turn to this page. We're skipping a page that we're not going to do about solving from roots. And so find this page. I think it's like 33, I want to say. And when you are ready to go, we will get started. So up to this point, you guys have been solving quadratics by either graphing, which you know is kind of a lot of work, a little bit tedious, and not always the most efficient. And so then you learned how to factor, and you guys are getting so good at it by now that it's coming like second nature. But unfortunately, factoring is not always a possibility. So sometimes you are given quadratic equations that cannot be solved by factoring because the equation is prime. So when in doubt, use the quadratic formula. We know mathematicians are brilliant, and somebody came up with this formula that works in all situations for all quadratic equations when you are trying to solve for the roots or the solutions or the zeros or the x-intercepts. So when you're trying to solve for x and you have a quadratic equation, you can always use the quadratic formula no matter what, in any situation, at any time. It's probably one of the most awesome formulas that you'll ever encounter in your whole entire life. In fact, I was just hanging out with some former students who are graduating this week from Woodbury High School, and they were reading their letters that they wrote in 7th grade in my class. And one of the girls, one of the questions that I ask is, what are the 3 most memorable things that you learned this year? And she wrote down the quadratic formula. And I was there, so I was like, can you still recite it? 1, 2, 3, go. And sure enough, she did it, and she sang the song that I'm about to teach you right now. And everyone was laughing because they're like, that's probably going to be on your placement and exams and things like that when you go to college. So this is definitely one that you're going to want to know. And because it's so important, I'm actually going to introduce a project to you when I return tomorrow. And the project's pretty simple. All you have to do is memorize the quadratic formula, but you're going to have to perform it for us in some way, shape, or form at the beginning of next week. So I will tell you more info about that when I return tomorrow. But for today, you're going to need your best singing voices available, and this is why I'm bummed, because I don't get to be there with you to hear you sing. So when I come back tomorrow, you're going to have to prove to me that you listened to this and you watched it, because I want to hear your beautiful singing voices. So Mrs. Thompson, you will have to be you will have to fill me in on how they did when I return as well. So you're the judge today. All right, so here we go. This is how I was taught the quadratic formula. I still remember the song to this day, but I know that you are much more clever than this, and so that's why I am giving you the project to memorize it in a different way. But for starters, just so you know how to use it and get the hang of things, here is how I learned it. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Woohoo! Hopefully you're giving me a round of applause right now. If you aren't, do it. So we're going to sing it again. I will sing it again for you, and then you better believe it, you're going to be singing when I ask here in just a minute. So here we go again. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Those of you who know the tune, it is the jingle of Pop Goes the Weasel. So another brilliant person replaced those words with the words to this formula, and it's a super handy way to remember this formula because it's kind of a lengthy one. So let's try it all together. Everybody clear your throats. Mrs. Thompson, I expect you to sing as well. Here we go. 1, 2, 3. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Not bad for the first try, not bad. However, I know you can do better. Let's do it again. 1, 2, 3. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Nicely done. All right, I'm going to give you one more opportunity, and I want the other class in Mr. L's room to wonder what's going on. So give it your all, as loud as you can be, but make sure that you're saying the actual formula correctly. Here we go. 1, 2, 3. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Ta-da! Nice job, nice job, nice job. Tomorrow when I come back, I will make you sing that. We will march around the room. You will be standing up. It's that important that you learn it, that important that you memorize it, and now, more importantly, I guess, is that you know how to use it. So I'm going to teach you that next. The example that we are given is x squared minus 6x plus 4 equals 0. So like I mentioned earlier, you could solve this by graphing, but to save some time and to show you how this formula works, we're going to do it that way. If you think about it, this cannot be factored because there isn't a GCF and there isn't any factors of 4 that add up to negative 6. So when in doubt, use the quadratic formula. Here's how it works. First, you need to be able to identify what is A, B, and C, because those are the variables that we use in the formula. So A, and I forgot my stylus, so I'm using my finger, so bear with me. A in this case is equal to 1 because there isn't anything in front of x squared, so we assume that it's 1. B is equal to negative 6. And C is equal to positive 4. So now it's just a matter of plugging it in. Here we go. X equals the opposite of B, or negative B. Since B is already negative, we change it to positive 6 because a negative 6 is actually positive 6. So some people saying X equals the opposite of B, but it doesn't roll as smoothly off the tongue. So X equals negative B plus or minus the square root of B squared minus 4 times A times C. I always put A and C in parentheses because when there are negatives involved, I see a lot of computation errors, so get in the habit of doing that just so that you're not making any mistakes or that you're not getting it confused with adding or subtracting because you're multiplying 4 times A times C. And then divided by 2 times A. Okay, so now it's just a matter of doing the math, and if you get a little antsy, you might make a mistake. So just go slow to go fast. Something that you might be noticing is this plus or minus. But some of you probably are already thinking ahead in the fact that when we solve quadratics, there's usually 2 different solutions because most parabolas go through the x-axis 2 times. And so we're going to solve this bad boy twice. The first time we're going to add, and the second time we're going to subtract. Okay, so first time, let's add. So x equals 6 plus the square root of negative 6 squared, which is positive 36, minus 4 times 1 times 4, divided by 2a. Order of operations, we treat the radical just like a set of parentheses, so you can go ahead and subtract this before you add it to 6. Still have the square root divided by 2. So 6 plus the square root of 20 divided by 2. Square root of 20 is not a number that I know off the top of my head, so you can go ahead and use your calculator to add 6 plus the square root of 20 divided by 2, and that gets you your answer. I'm thinking it's going to be somewhere around 5. And I don't have a calculator on me right now, so hopefully you all have the answer. Yep, okay, so I got x equals 5 and 23, or 5 and 24 hundredths if I round to the nearest hundredth. And so the second time around, I'm going to do x equals, x equals 6 minus the square root of 20 divided by 2. And if I plug that into my calculator, I get x equals 76 hundredths, which I know seems weird to see as a solution, but the reality of it is that you're not always going to get an x-intercept or a solution or a root that's a nice whole number or an integer. So that's why I love the quadratic formulas, because it works no matter what, even when your numbers are a little bit messier. So what I would write in my fancy braces here is 76 hundredths and 5 and 24 hundredths. And that's your answer. Okay, so I have complete faith in you guys that you are able to use a formula, take a formula and use it correctly, and so I'm not going to do a bunch more. I would like you to pause the video and just try practice problems number 1 and 2, and then press play again. I will show you the answers just to make sure you're on the right track. What I want to warn you about is just going slow to go fast and really paying attention to the detail, especially when it comes to the negatives, because that's where I see the most errors made, is in computation with the negatives. So be really, really careful with that, and go back and check your work if you need to, and also be careful with the calculator, because sometimes you just get calculator click happy and you start going crazy with that, and it leads you astray. So go ahead and pause the video, come back to check your work, and then I'll give you instructions for what I want you to do the rest of the hour. All right, so here are the answers for numbers 1 and 2, and if you went on, there's 3 and 4. Again, you're going to get some weird looking numbers because if the quadratic equation was able to be factored, then most of the time you end up with nicer numbers. If it's not able to be factored, then you're going to end up with some messy numbers, so that's okay. Let's round to the nearest hundredth just to be consistent. And if you need to do a couple more, I bet Mrs. Thompson could take over now. Otherwise, what I want you to do before you get started on the homework is half of the practice problems. So I don't care if you choose evens or odds, but do the half the practice problems, and then you can get going on your homework. Your homework is right here. That is what you should be working on after you have checked the practice problems with either somebody close to you or the answer key, which is up front on the table. Have a great rest of your day, and I look forward to seeing you tomorrow and hearing your beautiful singing voices. I hope the song is stuck in your head for the rest of the day. Thanks, Mrs. Thompson. Thanks, you guys. See you tomorrow.